the use of statistics in historical research. So this part is visible demographic analysis in historical research, studying population change through births, deaths, migration, and growth. So first I explain the figure with respect to this figure. The later on I will explain in detail. So the first figure, uh, demographic analysis studies changes in human populations over time. Okay, how the demographic analysis is helpful for the historical research. Just to explain this topic, I have taken the help of this poster. This poster consists of 30, perhaps 30 images. So these 30 images, first I explain, after that I shall go to the detail. Number two, population records provide valuable historical evidence. Number three, birth records reveal long-term population trends. Number four, death records help explain demographic change. Migration changes the size and composition of population. Then life expectancy reflects improvement in living conditions. Okay, this is the time path of life expectancy in years, which tells or reflects the improvement in living conditions. Population pyramid shows age and sex distribution, that is male female composition with respect to different age structure. How this structure or this pyramid can be formed, can be drawn in Excel. It will be shown later on. Natural population growth occurs when birth exceeds death. Natural growth rate equals to birth minus death divided by mid-year population into 100. Okay, so natural growth rate, the formula is birth rate, birth minus death, number of birth minus number of death, mid-year population into 100. For example, natural growth rate 1% means mid-year population is 50,000. Hypothetical data, birth is 1600 and death is 1100 in one particular nation. So the natural population growth is 1%. So the birth number minus death number divided by mid-year population. Hypothetical data. Similarly, this formula can be improved in this way. Crude birth rate measures birth per 1000 people. Similarly, crude death rate measures death per 1000 people. So if we get this data, the natural growth rate is equals to crude birth rate minus crude death rate divided by 10. Okay, so for example, suppose crude birth rate equals to 32 per 1000 population, crude death rate is equal to 14 per 1000 population. So the population growth is equals to 32 minus 14 divided by 10 equals to 1.8. In this way, we can calculate natural growth rate of population. So population growth measures demographic expansion. Demographic expansion. So this is with respect to bar diagram. This is line diagram. Okay, with the help of statistics, the historian can able to explain the population growth. Okay, which measures the demographic transition. And similarly, the famines reduces natural population growth. If there is a huge number of reduction of the natural population growth, it may reflect that there may be famine. Similarly, war increases mortality and alter population trends. If there is war, it increases the mortality and alter the population trend. Similarly, epidemics sharply increase death rate. Okay, if there is sharply increase in death rate, it may be the reflection of epidemics from the angle of historian. Similarly, public health improvement reduces mortality. So even if the record shows the reduction of mortality, that may reflect that public health improvement took place. Similarly, agricultural development supports population growth. Okay. Next, economic development attracts migration. So migration means people moving from one place to another place for job or for better life. Okay, so economic development, this also affects the population demographic. Migration redistributes population across the regions. We're coming from one place to another place, so it redistributes the population. Okay. Similarly, urbanization changes demographic structure. So by comparing two demographic structures of two regions, we can able to the population pyramid, we can reveal demographic differences. We can able to compare the demographic differences between two nations, two states, by comparing this pyramid. Similarly, census records reveal long-term demographic pattern. So from the census data, it can be explained. The long-term demographic pattern can be explained with the help of this line or time plot. Long-term trend explains demographic transition. Statistical analysis transforms records into evidence. Quantitative evidence strengthens historical interpretation. Historical records become measurable demographic data. Demographic analysis helps historians understand population change by studying birth, death, migration, life expectancy, and natural population growth. So, demographic analysis helps historians understand population change by studying birth, death, migration, life expectancy, and natural population growth. All these indicators are helpful for the historian to study the demographic pattern, demographic transition, demographic change, etc. Now, the demographic studies is just helping the birth rate, death rate, migration, life expectancy, population growth. For example, the year is given, birth is given, death is given. The historian can estimate natural population growth by using the formula mentioned above. How natural rate of population growth can be computed. The natural rate of population growth measures how fast a population grows due only to birth and death, excluding migration, immigration, and emigration. So the formula of natural rate of population growth percentage is equals to, just it is shown in the diagram, birth minus death by mid-year population into 100. So hypothetical data: suppose a kingdom in 1850 had mid-year population 50,000, number of birth equals to 1600, number of death equals to 1100. So using this formula we can able to calculate 1%. How can we interpret? The population increased naturally by 1% during the year. This increase was entirely due to birth exceeding death. Alternative method using crude rates. So if you already know the crude birth rate and crude death rate, so both expressed per 1000 population, then natural growth rate equals to crude birth rate minus crude death rate by 10. Okay, if for example the 32 is the birth per 1000 population and the CDR equals to 14 death per 1000 population, therefore the 32 minus 14 by 10 equals to 1.8%. So the population grows naturally at 1.8% per year. In this way, we can able to calculate. And the historian, how can it can be applied in historical research? The historians often estimate the natural rate of population growth using old census records, the parish registers, the baptism and burial records, or civil registration data. Comparing natural growth rates across decades can reveal the demographic effect of famines, wars, epidemics, improvement in public health, agricultural and economic development. This measure is particularly useful because it isolates natural demographic change from changes caused by migration. Another part is spatial statistics, that is historical GIS. Maps historical information such as battle location, trade routes, disease outbreaks, settlement patterns. For example, uh, actually this is spatial statistics, the use of spatial statistics from the historical perspective, when a historian or a researcher of the subject history can able to use these statistics, spatial statistics, for analyzing these information, and that battle location, trade routes, disease outbreak, settlement pattern, etc. For example, mapping is spread of a cholera epidemic across districts to identify clusters. Now, what is spatial statistics? The spatial statistics is a branch of statistics that analyzes data according to their geographical location. When combined with a geographic information system (GIS), historian can visualize and analyze historical events on maps to identify spatial pattern, clusters, and relationships. Unlike ordinary statistics, which focuses only on numerical values, spatial statistics answers questions such as: where did an event occur? Which regions were most affected? Are events clustered together or randomly distributed? How did historical phenomena spread? over space and time. So these are the research questions. These research questions can be answered with the help of spatial statistics that may be applicable to historical research. Now, historical GIS. Historical GIS, Geographic Information System, is a computer-based mapping system that stores, manages, and analyzes historical data linked to geographical locations. So this is historical GIS is a computer-based mapping system that stores, manages, and analyzes historical data linked to geographical locations. It enables historians to combine historical maps, census records, administrative boundaries, archaeological sites, trade routes, population data, climate records to produce meaningful spatial analysis. How can we apply this in historical research? So, mapping battle locations. A military historian studies the major battles of an empire. Suppose you have the data, the battle A, B, C, the latitude, longitude, and the year. Okay, here you know the Battle of Plassey here, the Battle of Boxer here. Okay, in 1757, 1764. Okay, you have the data record that the battle place, name of the place A, B, C, suppose, and latitude, longitude is given. If you plot this information into GIS map, you can get this type of diagram. Okay, or with the help of artificial intelligence, you can able to create such kind of map. Suppose you have this map. Okay, so the major battles took place 1757 to 1770. Latitude, longitude is given, and you got this map. Murshidabad, Bengal. Okay, so this is the place battle A, battle B, place battle C. The other information battle location, battle location. These are the battle location. Okay, B, A, B, C. This is major cities, major cities. Okay, everything is given. Krishnanagar, Bakura, Medinipur. The major rivers are given. The district boundaries are given, and the latitude, longitude is given. Okay, this is the map. This is the place where this battle took place. Now, with the help of this map, how the historian interpret the pattern. Suppose a river passes through the region where these three battles occurred. Okay, and this is the river Ganges. So battle A, battle B, battle C, all the battles took place near the river. So the historian can able to explain that battle A is close to the river, battle B is also close to the river, battle C is located downstream along the same river. Okay, close to the river, battle A, battle B close to the river, battle C to the downstream of the same river, downstream along the same river. So this suggests that military campaigns were concentrated near the river. The map may show that most battles occurred near major rivers, suggesting that river routes were strategically important. So in this way, the historians can able to explain the map. Okay. Similarly, mapping trade routes. Suppose if you have to prepare this map, you have to use GIS map satellite, or you can use the data and apply artificial intelligence. So you can able to prepare such kind of map. Suppose you have collected this data from your previous record or documents. Okay, the route A to B, hypothetical B to C, C to D, and the distance is also given. A to B distance is 150, B to C distance is 300, C to D 220, and the annual trade. Okay, annual trade is also given. 600, 900, 700 tons are given. Okay, this is the map you got. Okay, this is the map. The city A, city B, city C, city D. So city A, B, B, C, C, D. Okay, A to B, the distance is 150 kilometer, and the annual trade is 600 tons. Similarly, all the information, all the through this map, major cities, important trading centers are given. Important trading centers. Okay, river, port. Where the port is given. So all these maps, through this map, the historian can able to explain in this way. Trading centers. The cities represented by points, larger circles can indicate more important commercial centers. So all the information you are getting from this map. Now, how can you explain this? The trade volume. Thicker lines represents greater trade. For example, A to B, then a thin line 600 tons, B to C, thickest line 900 tons, C to D, medium line. Okay, medium line. So amount of trade is given through this line. Okay, now physical features. GIS can over river, mountain, forest, roads, ports, political boundaries. So this helps explain why certain routes were preferred, how the historian can able to explain with the help of statistics. Total trade volume 600 plus 900 plus 700 2200 tons. Total route length 670 kilometer, because 150 300 220 150, one is 150, okay, 150 300 220. So in this way, so the expense. Similarly, average trade per route. So total trade divided by 3 route equals to average trade per route. The busiest route B to C 900 tons. The shortest route equals to A to B 150 kilometer. Okay, so the historical interpretation will be like this. From the GIS map, a historian might conclude that city B served as a major commercial hub because it connected two important trade routes. The B to C route carried the highest annual trade, 900 tons, indicating it was the principal economic corridor. If the GIS overlay showed that these routes followed a river or crossed fertile plains, it would suggest that geography strongly influenced trade patterns. Such spatial evidence helps explain the rise of prosperous cities, the movement of goods, and the development of regional economies. A well-designed GIS map makes these patterns immediately visible, allowing historians to combine geographical visualization with quantitative analysis for stronger historical conclusions. The busiest trade routes often passed through river valleys or coastal regions, explaining the economic growth of nearby cities. Similarly, suppose you have the data on disease outbreak. Suppose the cholera epidemic affected several districts. District ABCDE cholera cases, number of cases are there. So you have to convert this data into GIS map. Okay, uses different color to represent disease intensity. There are several softwares are there. Global Mapper, GIS software. Okay, mapping softwares are there. You can able to use the software, or you can use artificial intelligence chat GPT to put this and just say the GPT that I want to make this chart. Okay, make the chart using this data. So it will provide the chart. Okay, then you can explain. The map reveals that district B, C, and E form the contiguous high incidence area. On the basis of data, you prepare this map. This map. Okay, this map 1 to 50 cases. Okay, low disease 51 to 150 cases, moderate 151 to 200 cases, 201 to and above very high. So the this thick more the red color implies the 201 and above cases are there, cholera cases are there. So district A B C D E and the number of cholera cases are there. So you got this map. Okay, you got this map. Now how to interpret? The map shows that district B, C, and E form a contiguous high incidence area, dark color. This clustering suggests that the cholera epidemic may have spread through contaminated water sources because water is flowing within these areas. Okay, river flows and waterways, movement of people or trade along transportation routes. Such spatial pattern help historians reconstruct the portable routes and factors of disease transmission. Okay, so in this way, with the help of GIS map, that is known as spatial statistics, the historian can able to interpret. The map reveals that district B, C, and E form the contiguous high incidence area. The clustering suggests that the epidemic may have spread through contaminated water sources or along transportation routes, helping historians reconstruct the pattern of disease transmission. Okay, so settlement pattern, another kind of data. Suppose an archaeologist records ancient villages, village A, B, C, D, E, and the number of population is like this. Okay, on the basis of this information, you have to plot it on GIS map. It becomes clear that larger settlements cluster along rivers, while smaller settlements are located in hilly regions. Okay, so you got this map after plotting, transforming that data. So you got this map. Okay, this map indicates that population, number of people, 150 and above. Okay, 50 and 149 medium, and below 50 that is small. It is classified in this way. Below 50 means small, 50 to 149 medium, and 150 and above large. Okay, river, moving on. Okay, similarly agricultural land is given, agricultural land. Path is given, or route is given, this dotted line route. Okay, hilly region, these are hilly region, hilly region. And the vegetations are going on, and village, these are the village. Okay, and that this is the data A B C D E, the village population, and number of category of the population: large, 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 small, small. How can we interpret? The map shows that larger settlement A, B, and C, A, B, and C, larger settlement are located along river. Okay, larger settlement are located near about river. Okay. While smaller settlements D and E, smaller settlements are situated in hilly regions away from water sources. So this pattern suggests that access to water was essential for drinking, agriculture, and daily use. Fertile land along rivers supported larger populations. Hilly areas with limited resources supported only small settlements. Therefore, access to water and fertile land strongly influenced the location and growth of ancient settlement. So, in this way, a historian would not simply describe the map, they would interpret the spatial pattern and relate it to historical processes. Below is an example of how a historian might explain the image in a research paper or classroom. Historical interpretation of GIS settlement map. The GIS map depicts the spatial distribution of 5 hypothetical ancient villages. Village A 150 population, hypothetical, B 170, C 180 are located along the river in the fertile plains, whereas village D 20 and village E 15 are situated in hilly regions away from the river. So the map reveals a clear pattern of settlement clustering. The three largest villages are concentrated near the river, while two smallest settlements are located in areas characterized by rugged terrain and limited access to water. So this spatial arrangement suggests that physical geography strongly influenced settlement location. Rivers provided a reliable source of drinking water, irrigation for agriculture, fertile alluvial soils, fishing resources, and convenient transportation routes. These advantages supported larger populations and encouraged the growth of permanent settlement. In contrast, the hilly regions offered less fertile land, more difficult terrain, and limited water availability. Consequently, only small settlements developed in these areas, probably relying on pastoralism, the forest resources, or subsistence farming. From a historical perspective, the map demonstrates that environmental factors played a significant role in shaping human settlement pattern. The concentration of large villages along a river valleys indicate, indicates that access to natural resources was a key determinant of population growth and economic development. In this way, historian can able to explain the possibilities with the help of this spatial historical or GIS map. How a historian supports this conclusion? A historian would combine the GIS evidence with other historical sources such as archaeological excavation reports, ancient land revenue records, historical maps, river course studies, inscriptions mentioning settlements, agricultural records, travel accounts, and chronicles. By integrating these sources with GIS map, the historian can strengthen the interpretation that river systems were the foundation of settlement expansion. This suggests that access to water and fertile land strongly influenced the settlement location. So, statistical methods used in spatial analysis, the historians use GIS, often apply statistical techniques such as spatial distribution analysis, which examines whether events are concentrated or dispersed across space. The nearest neighbor analysis, it tests whether historical sites or events are clustered, random, or evenly spaced. The kernel density estimation, that is heat map, identifies hotspots such as battlefields, crime locations, or epidemic centers. Spatial autocorrelation, uh, it measures whether nearby areas have similar values such as high mortality or high literacy. The hotspot analysis, it detects statistically significant clusters of high or low values. The interpolation estimates values in locations where historical records are unavailable. This is another statistical technique when to calculate the values in locations where historical records are unavailable. Okay, so the research comprehensive hypothetical example. The research question: how did cholera epidemic spread across 10 districts in 1895? So this is the 10 districts and this is the number of cases. Okay, now use this GIS map. After plotting this data in GIS map, or if you don't have GIS map, just plot this into chat GPT, or use the and tell the GPT that give the form the map. Okay, create the map using this data. You can get this type of data, this type of result. Okay, the cholera epidemic in 10 districts 1895. Okay. So these are the cases. So the 0 to 5 cases very low, 26 to 50 cases low, 51 to 150 cases moderate, 151 to 200 cases high, 201 and above very high. So this, there is no hard and fast rule how to classify this one. So it depends on case to case or through some introspections. Okay, and using some intelligence it can be classified into different classes in this way. So this is the data, and the kernel density hotspot map looks like this. Okay, the spatial autocorrelation functions is equals to 0.46 p values. It can be interpreted in this way: districts with high or low cholera cases are clustered together more than would be expected by chance. This map shows a clear hotspot of cholera district in C, D, E, I, and J. C, D, I, E, and J. Okay. And these districts are adjacent and located along the river, Great River. Okay. Along the river, all these are surrounded by river. Okay. Kernel density analysis highlights that this concentrated zone of high incidence, the positive Moran's eye indicates that neighboring districts have similar cholera rates. The epidemic was not randomly distributed. The pattern suggests that contaminated river water and river-based transportation likely contribute to the spread of cholera in 1895. Districts C, D, E, I, and J appear adjacent and form a clear hotspot. Most of these districts are located along the rivers. A historian would explain this map by integrating spatial evidence, GIS, statistical analysis, and historical context rather than merely describing the colors or numbers. A possible explanation given below. The historian interpretation of GIS map. The GIS map illustrates the spatial distribution of cholera cases across 10 districts during the epidemic of 1895. The districts are shaded according to disease intensity with darker colors representing a larger number of cholera cases. At first glance, the map shows that cholera cases were not evenly distributed across the regions. District C 180 cases, District D 210 cases, District E 195 cases, District I 170 cases, and District J 200 cases recorded substantially higher number of cases than the remaining districts. More importantly, these 5 districts are geographically adjacent, forming a continuous high incidence cluster, that is hotspot. The kernel density map further confirms this observation. The darkest red area is concentrated over the district C, D, E, I, and J, indicating that this epidemic reached its greatest intensity within this part of the region. Rather than isolated outbreak, the disease formed a continuous zone of transmission. Another significant feature is the major river flowing through the hotspot. Most of the highly affected districts lie along the same river corridor. The spatial relationship suggests that the river may have acted as an important pathway for the spread of cholera during the 19th century. Rivers served not only as the principal source of drinking water but also as the main transportation network for people and goods If the river became contaminated, settlements downstream would also be exposed to the disease. This the map also reports a positive Moran's I value with a statistically significant p value less than 0.01. Moran's I is a measure of spatial autocorrelation indicating whether the neighboring areas have similar values. A positive value means that districts with high cholera incidence tend to be located near to the other districts with high incidence, while districts with low incidence tend to be grouped together. Therefore, the observed clustering is unlikely to be due to random chance. In contrast, district A, B, E, G, and H experienced relatively few cholera cases. Their lighter shading or greater distance from the hotspot suggests that they were either less exposed to contaminated water, had lower population densities, or were less connected through river and transportation network. From a historical perspective, the GIS analysis indicates that the epidemic spread through geographical connectivity rather than randomly. Rivers, transportation routes, and human movement probably facilitated the transmission of cholera between neighboring districts. The epidemic appears to have propagated along the river corridor, where the settlements are more densely populated and more closely connected. The historical conclusion: the GIS analysis demonstrates that the 1895 cholera epidemic exhibited a clear spatial pattern rather than a random distribution. District C, D, E, I, and J formed a statistically significant hotspot of disease incidence along the major river. Kernel density estimation identifies this region as the principal outbreak zone, while the positive Moran's I statistic confirmed strong spatial clustering of cholera cases. These findings suggest that contaminated river water and river-based transportation played a central role in transmitting the disease. By integrating historical records with GIS and spatial statistics, historians can reconstruct the geographical pathways of epidemic diffusion and better understand how environmental conditions, transportation network, and settlement pattern shaped the spread of infectious disease in the past. So, how a historian would verify this interpretation? A responsible historian would not only rely on GIS map alone, they would collaborate the sorry the corroborate the findings using multiple historical sources, including health department reports documenting cholera outbreak, mortality registers showing death by the district, the historical maps of river, canals and settlements, census records to assess population density, municipal sanitation reports on water supply and sewage disposal, the travel diaries and newspapers describing the progress of the epidemic, the meteorological records, especially floods or heavy rainfall that may have contaminated water sources. By combining GIS, spatial statistics, and documentary evidence, the historian can construct a robust, evidence based explanation of where, how, and why the cholera epidemic spread across the region in 1895. So, with these few words, I am concluding today's video. Thank you very much. Thank you for your patience hearing